the electric field. What is electric field? Just understand. Let's suppose we have this charge right here. We have 2 coulombs of charge. All right. So when we
Mm-hmm.
have this 2 coulombs of charge, so first of all, you have to understand what is a charge and how is a charge developed. And how is a charge developed, right? So understand one thing. I hope you understand that, in nature, there is a lot of matter.
Yep.
What is matter? Anything which has mass and occupies space.
Yeah.
So, and we know that the smallest entity of matter is atom. And inside the atom, we have electrons. Yes or no?
Yeah.
So, my point is that when we have this particular atom and there is this nucleus in which we have certain protons in it, and outside it, we have the electrons.
Yes.
So, what I'm doing is you must have read these kind of experiments. Let's suppose we have this rod and we have a cloth. And if we rub this cloth over here, over the rod,
Mm-hmm.
so what exactly happens? There is a lot of friction, isn't it? There's a lot of
Yeah.
friction. And because of that friction, because of that heat, the electrons from the rod, they went into the cloth. Do you understand my point?
Yeah.
So when they went into this particular, the cloth, so cloth gained electrons. And what exactly is going to happen? The rod gained positive charge.
Yes.
So basically, what do you understand by charge? In reality, there is only negative charge. But what
Yeah.
exactly happens is that, when a certain object, normally what happens, whenever we talk about a particular object A,
Mm-hmm.
and we say that this object is neutral, that means it has equal number of protons and electrons. If it has 100 protons, it would have 100 electrons as well.
Yes.
Because the charge of one electron, the absolute charge of one electron is what? The absolute charge of one electron is minus 1.602 into 10 raised to the power minus 19 coulomb. You understand?
Yeah.
This is the absolute charge of the electron. Absolute charge means the exact value of charge that an atom has. The exact value of charge that an electron has. You understand?
Yeah.
So that was the thing. So it says the absolute value of charge is going to be what? Minus 1.602 into 10 raised to the power minus 19 coulomb. So coulomb is first of all the unit of charge. Okay, unit of charge is coulomb.
Yeah.
Understood? Now let's suppose
Yes.
this body A, it loses 3 electrons. And what is the absolute charge of a proton? Just tell me. What is the absolute charge of a proton? The absolute charge of a proton is plus 1.602 into 10 raised to the minus 19 coulomb.
Coulombs. Yeah.
So just have a look at the magnitude. The magnitude value is the same.
Yeah. It's only the sign.
It's only the sign which is changing. That means protons are positively charged
Yes.
and electrons are
Negative.
negatively charged. Yes or no? Protons are positively charged and electrons are negatively charged.
Yes.
So my point here is that when we are talking about the electrons and the protons, and here now understand one thing. We are talking about the absolute charges, right?
Yeah.
So if I take the charge of one electron is minus 1.602 into 10 raised to minus 19 coulomb over the charge of one proton, which is going to be plus 1.602 into 10 raised to minus 19 coulomb. So this gets
Mm-hmm.
cancelled. So the value of 1 electron upon 1 proton shall be -1 over +1.
Yes.
So this is going to be my relative charge. This is going to be my relative charge.
Yeah.
You understand? Relative charge means a comparative charge, a comparable charge. Like I would just tell that, the values are the same. 1:1 ratio means what? Ratio never gives you the exact values. Ratio gives you an idea.
Yeah.
Ratio will tell you that 1:1 is the value. You know, 1:1 is
Mm-hmm.
the value of the charge. And what
Yes.
is happening? 1 is +1, so 1 is -1.
-1.
So it is a relative charge. The actual value is this for the charge. I hope you're understanding my point.
Yes.
Now understand from here what is happening. Similarly, if I say the alpha particle, so I would say the alpha particle's charge is +2. But in reality, this is a relative charge.
Yeah.
Relative to what? Relative to proton.
Yeah.
That, ma'am, the charge of an alpha particle is double the charge of the proton. Are you understanding?
Yes.
So my point here is what? That we generally deal with the relative charges. But what if I talk about the absolute charge? If I talk about
It's
the absolute charge of alpha particle, it would be
2
2
and
times the charge of one proton, which is plus 1.602 into 10 raised to the minus 19 coulomb.
yes.
So that should be what? It should be 40, it should be 12, it should be 3.204 into 10 raised to the minus 19 coulomb. Are you understanding?
Yes.
That is the concept. So
Okay.
what I'm trying to tell you here is, just understand, what I'm trying to tell you here is, I am trying to tell you the absolute charges are basically the actual charges, and we generally deal with the relative charges. So going forward, if I say the charge of electron is -1, it should be clear to you that this is not the actual charge. And if I talk about the proton, if the charge of proton is +1, again it is not the real charge, it is a relative charge. I hope you're understanding. And
Yeah.
1 electron upon 1 proton, when I am saying, so you understand the unit coulomb and coulomb also gets cancelled. So you have to understand that relative charge has no unit. Relative charge has no unit because it is a ratio.
Yes.
So coulomb cancels coulomb. Yes or no?
Yeah.
Now let's talk about the previous example. So now let's suppose if I say the body A, it loses 3 electrons. So 3 electrons come out of the body, and now this body will have 97 electrons, isn't it?
Yeah.
And if the charge of one proton is +1, the charge of 100 protons shall be +100, isn't it?
Yeah.
So this body will contain 100 positive charges. I hope you're understanding.
Yes.
And this will contain -97 charge because there are 97 electrons. So the
Yeah.
charge of this electron shall be -97. I hope you're understanding.
Yeah.
What is the point? What is the point? The point here is that, ma'am, this body will overall have a +3 charge.
Yeah.
So no. So
Yes.
when do you say that a body has a positive charge? When the number of protons are more than the number of electrons.
Yes.
And thereby, it could be the reverse would also be true. If, for example, this would gain, some more electrons. Initially, it had 100 protons and 100 electrons.
Mm-hmm.
And let's suppose it gains 6 more electrons. So now the
Mm-hmm.
new electron shall become 106 electrons inside the body.
Yes.
So if the charge of one proton is +1, so the charge of 100 protons shall be +100.
Yeah.
And the charge of one electron is -1, thereby the charge of 106 electrons shall be -106.
Yeah.
So the net charge shall be -6.
6.
So
Yep.
basically, somebody acquiring a positive charge or somebody acquiring a negative charge is all because of the electrons. Because if you look at the nucleus, no proton or no neutron can come out of the nucleus. It is only the electrons which can come inside and outside.
Yeah.
So when electrons leave the atom acquires a positive charge.
Yeah.
right? And when
Mm.
and when it gains the electron, so the atom
Then it's
acquires a negative charge. And when nothing happens, the atom is neutral
true.
and it has
Yep.
zero charge. I hope you're understanding.
Yes.
So first thing you have to understand that this is the basic concept that you have to understand. Now, second thing you see. Now, let's suppose we take an example of a metallic sheet. Now, what exactly happens in the case of a metallic sheet? Just see now. When we are talking about the metallic sheet, so we have this atom, we have another atom, we have
Yeah.
another atom, we have another
Yes.
atom, we have another atom, isn't it?
Yep.
Now, first of all, you have to understand that in nature, all atoms are not of the same size.
Yeah.
Few atoms are bigger,
Some are small.
some
Yeah.
are small, right? And some are
Yeah.
small, correct? But generally, the non metallic atoms are smaller. The ones which are smaller are non metallic, and the ones which are bigger are metallic. The ones which are bigger are metallic. Are you understanding?
Yeah.
Right? Now, what is the point? The point is that if, for example, we are talking about a big atom, so there is a small nucleus at the center
Mm-hmm.
which has protons and neutrons and protons and neutrons.
Yeah.
And there are these electrons, isn't it?
Yeah.
So we have it here. You understand the last electron. Because the atom is bigger, I hope you're understanding that this last electron is very far off from the nucleus.
Yep.
Now, when it is very far off from the nucleus, you have to understand this a very, very important concept here that when this last electron is very far off from the nucleus, do you realize that the force of attraction of the nucleus, the force of attraction of the nucleus
Mm-hmm.
on these electrons would be reaching from a very far off distance, and hence this force of attraction would be less.
Lesser. Yeah.
It will be less force of attraction.
Yes.
You understand my point? It would be less force of attraction.
Yeah.
And when it is less force of attraction, what exactly does that mean? You tell me. When it is less force of attraction, what exactly does that mean? That these electrons, now understand what is happening. Now, let us suppose I provided heat. I heat such an atom.
Mm-hmm.
So this heat shall be absorbed by the atom.
Yeah.
This heat is absorbed by the atom. Yes or no?
Yep.
Now, if this heat is absorbed by the atom, what exactly does that mean? You tell me. If this heat is absorbed by the atom, you know, so that heat is in reality is being absorbed by the electrons of this atom. This heat is being absorbed by the electrons of this atom. Are you understanding?
Yeah.
And when this heat is being absorbed by the electrons of this atom, these electrons are generally rotating, they're moving on their orbits.
Yes.
Now you realize one thing, understand one thing. There are two things happening here. When this electron is present on its orbit, right?
Mm-hmm.
So this electron is actually being attracted by the nucleus, isn't it?
Yeah.
This is being attracted inside. So do
Yes.
you realize that, if there is only the force of attraction inside, this
Mm-hmm.
electron might have a fair chance of falling inside the nucleus, isn't it?
Yeah.
But still, it is not falling. In reality, there is one experimental fact that when proton and electron meets, a lot of energy is produced.
Yeah.
A lot of energy is produced. बहुत energy बनती है. And when a lot of energy is produced, my point is that it could be sort of explosion as well. So
Yeah.
how is it possible that in our surroundings I cannot see any fire? Why I cannot see any fire? You tell me. Why I
Because
cannot
it's
see
not.
any fire? You tell me.
Because they don't meet.
Because they don't meet. So what exactly is happening which is holding these electrons on its own orbit?
Mm.
There isn't, it is consistently moving. And when you rotate something on the circular path, it's like when you hold a thread and that
Mm-hmm.
thread is tied to a stone on one end and you start rotating it on in your hand. Don't you
Mm-hmm.
don't you feel an outward pull? Don't you feel that the thread will sort of break and the stone will fall off?
Yes.
So it's the same thing. If the electron is moving in the circular path, don't you think that it is going to be pushed away?
Yes.
So in normal scenarios, the inward attractive force is equals to outward, and this is called outward centrifugal force. Centri means central, fugal means away. And why is that centrifugal force coming into play? Because the electron is consistently rotating in the circular path. And because of that circular rotation, that electron will sort of move on the outside. Are you understanding my point?
Yeah.
So normally this is happening. And that is why this electron is, held on its own position on the electron's orbit. But when you heat it, so that heat is absorbed by the electron,
Yep.
and that heat energy, so electron does what? Absorbs heat.
Yes.
And when electron absorbs heat, it forms what? It takes that heat and converts that heat into its own kinetic energy. And when its kinetic energy increases, it starts to rotate even faster.
Yeah.
And when it starts to rotate even faster, that means the outward force keeps on increasing and increasing and increasing. So there
Yeah.
comes a time that this attraction is being broken down
Mm-hmm.
and the electron leaves the atom. You understand my point?
Yeah.
So this is an explanation to the point that how does an atom loses an electron? Okay? How does an atom loses an electron? So my point is that if the atom is bigger, and here we have the nucleus in the center, and here we have the electron.
Mm-hmm.
So this electron, because it is very far off, so there is very less force of attraction on this electron. There is very less force of attraction on this electron, and which is why what is happening? This electron with little bit of energy provided from outside, with little bit of heat energy provided from outside,
Mm-hmm.
this electron can be removed. Yes or no?
Yeah.
This electron can be removed. But my point is that if the atom is smaller, then what is going to happen?
You need more heat energy to remove it.
Exactly, because it is closer to the nucleus. So you will have to provide a lot of energy from outside. And that is why the smaller atoms, wherever they are present, they will not lose their electrons very quickly. And because they will not lose their electrons very quickly, what exactly is happening? Tell me, because they're not able to lose their electrons very quickly, what is happening? That these electrons, since they're not being removed easily,
Mm-hmm.
you know, so we have no free charges, we have no free electrons, isn't it?
Yeah.
And when we have no free electrons, it means what? It means what? That no conduction of electricity.
Yeah. No
No
free
conduction
moving
of
electricity.
exactly. So when I say metals are the good conductors of electricity, what is the reason behind that? When I
There's free
say
moving electrons in
exactly.
the.
So when I say metals are good conductors of electricity, so the reason lies behind the fact that they have big atoms. Metals are the good conductors of electricity. So it means what? that the generally when we talk about the individual atoms of metals, they are generally bigger in size. And when they are bigger in size, so just by the surroundings heat, it's not possible. See, understand, no matter where we live, our surroundings will always have some amount of heat in them. And that
Yeah.
heat is enough. That heat is enough to do what? That heat is enough to sort of, you know, to for these big atoms to absorb heat from the thermal energy from the surroundings, the thermal energy of surroundings. You understand?
Yeah.
And because of the thermal energy of the surroundings, that big atom needs a little bit amount of energy. And that
Yeah.
little bit amount of energy is enough that, when we look at this atom, there might be a lot of shells. So since the
Mm-hmm.
last shell is, the last shell is the farthest. So the electrons from the last shell are actually removed.
Yeah.
Do you understand? Electrons from the last shell are actually removed.
Yes.
Do you understand my point?
Yes.
So basically, the last shell really doesn't have any value. So we can just remove these last shells because, when there is no electron in these last shells, these electrons are set free. And now these
Yeah.
electrons, they keep on moving randomly in different directions because they have this thermal energy. Are you understanding my point?
Yes.
Any doubts in this?
No.
Okay.
Yeah.
So this is the basic concept of thermal energy. You understand? And this is called electron pool model. This is called electron pool model. You understand my point? So we will
Yes.
say that these metals, because of their big size, they have free mobile electrons. And because we have free mobile electrons, so we have a charge carrier because electrons are negatively charged. But
Yes.
these charge carriers are randomly, these charge carriers are randomly moving in different directions. In such a way that, if we have this A electron, it is moving here, there might be some B electron which is coming just towards it to hit it.
Yeah.
And this is how they cancel each other's motion. So if one electron C is moving here, there might be some D electron which is just coming to hit the C electron. You understand my point?
Yes.
So this is the concept, right? Now, when we are
Yeah.
talking about the metals as the good conductors of electricity, what exactly does this mean? Just see. So here, what is happening? Just have an understanding. Now, here in this example, right?
Yep.
So every metal, now understand, every metal can conduct electricity. Every metal can conduct electricity, right? But
Mm-hmm.
under what conditions? So one condition we know that, they have free electrons. Definitely it can. But will it conduct electricity always? Will it conduct electricity always or under certain conditions?
Certain conditions.
Yes. So understand one thing. Let's suppose we have this iron chair, okay? We
Mm-hmm.
have this iron chair. All right.
Yep.
And a person is sitting onto it.
Mm-hmm.
And again the same chair, right? And the same person is
Mm-hmm.
sitting onto it again. Now, what is happening? You know, what is happening? This is the person. What I do
Mm-hmm.
is just as a prank, I take a socket, the electricity
Mm-hmm.
socket, and I connect it to the, you know, I connect a wire to that and I connect to this chair.
Mm-hmm.
So the person will get an electric shock.
Yes.
But here in case one, the person was not getting an electric shock. But
Yeah.
in case B, the person will. What has changed?
Yeah.
What has changed? This was an iron chair in case 1. We still have an iron chair in case 2, case B.
Yeah.
Iron definitely is a metal. Definitely is a metal. Metals have free electrons. Metals have free electrons. But thereby, even then, the person A sitting on a conductor is not getting an electric shock.
Because there's no electricity flowing through.
What is electricity? That's the point. Electricity is made by electrons. So here what is happening, you understand. Here, the electrons are there. These red dots are just nothing but the electrons. And these
Mm-hmm.
electrons are randomly moving. They are just cancelling out each other's motion.
Mm-hmm.
They are cancelling out each other's motion. Are you understanding my point?
Yeah.
Any doubts in this?
No.
And when they're cancelling each other's motion, so they do not affect the person. They do not enter the person's body. Because we also have a lot of fluid in our body, right? We have water in our body. And we also have
Yeah.
salt in our body. So salts are also made up of electrons only.
Yep.
Now, here what is happening? So just understand. So we have this particular metallic sheet, and let's suppose we have these atoms. So what am I drawing? I'm drawing the inner shells, and the outer
Mm-hmm.
shells have been removed because those shells are basically lost. Why are those shells lost? Because the electrons have left those shells,
Yeah.
right? And in the normal scenario, in case A, the person was not actually, experiencing the electric shock. The reason
Yeah.
was the electrons are randomly moving. But now when I connected it to a socket, right? When I
Mm-hmm.
connect it to a socket, so I hope you understand the socket is basically the socket something looks like this. The 3-pin socket looks like this. So
Yeah.
one is a positive terminal, one is a negative terminal, another one is a neutral terminal.
Mm-hmm.
You understand my point?
Yeah.
So my point here is if one is a positive terminal and if one is a negative terminal, what exactly does that mean? That ma'am, the one which is a negative terminal makes the entire end of the sheet negative, and the one which is a positive terminal makes the entire terminal of that sheet positive. And the
Yeah.
electrons, if electrons are also what? Negative. So these electrons, they were randomly moving, isn't it?
Mm-hmm.
But because they were randomly moving, initially when there was no battery, but now there is a battery. And the
Yeah.
negative should do what? A one small negative charge is repelled by strongly negative terminal, isn't it?
Yeah.
So what is happening? This negative is repelling this electron, and this electron is also negative. So negative repel.
Yeah.
And when negative repels, what exactly does that mean? Don't you think that the electrons shall be forced to move forward in a straight line?
Yeah.
So all these electrons, because there is this negative charge which has developed here, okay, these electrons shall be pushed forward. And now they are moving in a single direction. So now nobody is cancelling each other's motion. They are all moving in a straight line. And this unidirectional flow of electrons and this unidirectional flow of electrons is called electricity or electric current. You understand my point? Yes, Pradiksha,
Yes. Yes.
right? So this is
Yeah.
called this is basically going to make the electric current. So when we are talking about the electric current, what exactly does that mean? The unidirectional flow of electrons is called as the electric current. And now
Okay.
you see, so here they are not cancelling out each other's motion. So the velocity, the velocity with which these electrons are moving forward, are moving forward, right? The electrons which are moving, right? That velocity is called as the drift velocity. That velocity is called as the drift velocity. So when we are talking about the drift velocity, what exactly does that mean? The drift velocity is velocity with which the electrons are actually trying to move forward in a straight line.
Yeah.
So in reality, the electrons they move from negative terminal to positive terminal.
Positive.
And the reason is that electrons are negative, so electrons negative are being repelled by the negative terminal, isn't it?
Yeah.
So that is the concept. So velocity with which the electrons are moving forward is called as the drift velocity. Understood or not?
Yeah.
But in reality, now today we know that electrons are free. So this is the actual direction of the flow of current. Actual direction of flow of current. What is that? The actual direction of the flow of current would be from negative terminal to positive terminal. All right.
Yeah.
Because the electrons are the moving entities in an atom. What is set free? The electrons are set free.
Yeah.
So when these electrons are set free, I hope you're understanding that these electrons are basically moving from one end, from the negative end to the positive end. I hope you're understanding.
Yeah.
Now my point here would be what? My point here would be that if in reality earlier, when it was not clear who is free, who is not free, you know, and in an atom it was not clear to the scientists that whether the protons would be moving or whether the protons would be fixed, whether the electrons would be moving or whether the electrons would be fixed. At that point in time, the scientists thought that the protons are moving. Protons are the moving particles. At that time, it was thought that protons are the moving particles.
Mm-hmm.
And that, according to that, scientists told us that what? That if protons have to move, so if you connect a metallic sheet, and if protons are the moving particles in between the atoms, are you understanding?
Mm-hmm.
So what is happening? The protons will be repelled by the positive terminal. So then the protons shall move from positive to negative.
Negative.
But since entire discovery actually took place, a lot of discoveries took place, a lot of inventions took place, and scientists were still not clear who is the moving particle, whether electron is moving or whether proton is moving. So till then the scientists did what? Till then the scientists discovered everything, and they observed and they assumed that protons are movable particles. So they always said that the direction of the current is from positive to negative.
Okay.
Are you
Yeah.
understanding? So this is, but now after the discovery of electron, they realize that, oh no, we have done everything wrong. So now even today, they would say the electrons, the charged particles are coming out of the positive terminal of the battery. This is a symbol of the battery. This is a symbol of the battery. Okay.
Mm-hmm.
So now today as well, that when they connect a battery to some resistor or something, they would say the current is coming out from the positive terminal, but the positive terminal can only repel a proton. So the scientists or the book authors, they assume the proton to be moving in the wire, but in reality, actually the current should flow from the negative terminal.
Negative
Are
to
you understanding?
positive. Yeah. Yes.
I hope you're understanding. So this is the
Yeah.
concept. So this is the actual flow of, so this is the actual current direction, actual flow of electrons. Okay. And this is the
Mm-hmm.
conventional flow of electrons. Conventional means just on the basis of some assumption. Conventional flow of electrons.
Yeah.
Are you understanding my point?
Yes.
All right. This is the concept. So there are two. directions of the flow of electron. We would be dealing, I would be explaining you everything in terms of the actual flow of electrons. But the book authors, they would be writing down this thing. But this could actually not explain anything, in reality, because, if protons would be moving, then the entire theory actually, it doesn't go wrong. Everything I'll have to say again, everything in the opposite way. So I would be
Yeah.
explaining you in terms of the actual flow of electrons because that's more understandable, easily understandable. But you don't have to get confused between the conventional flow of electrons or the conventional flow of the electric current and the actual flow of electric current. Understood up till now? Just tell me. Okay.
Yes.
And I hope you're also clear with the concept of drift velocity.
Yeah.
And drift velocity, we are going to assume and we're going to write it down as Vd. All right.
Okay.
All right.